All right, this is 3.2, the graph of a function, really short lesson. So just going over, again, what it means to be a function, but this time given the graph. Okay, so remember that a function exists if every x in the domain has exactly one y in the range. Remember, 1x goes to 1y. We can test if a graph is a function by using something called the vertical line test. So what the vertical line test is that what you will do is draw a vertical line through a graph, and if it intersects only once, then that graph is a function. If it intersects more than once, then that graph is not a function. So let's see what we mean by that. So we want to know, are these graphs functions? And all we have to do is prove it by the vertical line test. Draw a vertical line through the first one, and we only intersect once, which means this is a function. All right, the one on the right, y equals x cubed, draw a vertical line through it anywhere, and no matter what, you will only intersect it once. So this is a function. Then we look at the graph of a circle. We draw a vertical line through the circle, and we notice that we intersect twice, which means the circle is not a function. And then we have the graph of a horizontal parabola. No matter where you draw a vertical line through it, you see you will always intersect twice. So this as well is not a function. Okay, that's it. That's the vertical line test. So given a graph, you can prove whether it's a function or not by using the vertical line test. Okay. Now, learning how to read a graph is very, very important. So maybe I can, yeah, that's all I need there. Okay, so obtaining information in a graph, knowing how to read a graph is always important, okay? There we go. So we just want to answer the questions and read the information from the graph correctly. So for the very first question, it says, what are f of 0, f of 3 pi over 2, and f of 3 pi? So what this is asking, if we look at the first one, this says, in function notation, this says, when x is 0, what is the value of y? So when x is 0, what is the value of y? So we can look at our points here. So we know that this is an xy chart, right, or graph. So here is where x is 0 at. So when x is 0, we look for a point. When x is 0, y happens to be 4. That's all we look for. So we're looking at the points. When x is 0, y is 4. So we write that. And then the next one says, when x is 3 pi over 2, what is the value of y? And again, look at your points. When x is 3 pi over 2, y is 0. And in the very last one, when x is 3 pi, what is the value of y? When x is 3 pi, which is down here, y is -4. So -4. Okay. 2. what is the domain of the given function? All right, remember, domain deals with x values. So when we state domain, we always start from the smallest x value to the largest x value. So on this graph, where do my x values start? Well, my x values start at 0, right? My x values start at 0. So we say bracket 0. And where do they end? Well, come down the number line, and it looks like we end at 4 pi. So 0 to 4 pi. All right, and then 3. What is the range of the given function? And range deals with y values. So we start at the smallest y value, which we see is -4. So we'll say bracket -4. And we end at the largest y value, which happens to be 4. Okay, and then 4. List the intercepts. All right. Well, first, let's look for x-intercepts. All right, and remember, x-intercepts are where you intersect the x-axis, and it's where y is 0. So we have our first x-intercept there at pi over 2 and 0. Our next one is at 3 pi over 2 and 0, 5 pi over 2 and 0, and 7 pi over 2 and 0. All right. And then our y-intercept is where we, of course, intersect the y-axis. So my y-intercept is just at 0, 4. All right, cool. Okay, then 5. How many times does the line y equals 2 intersect the graph? Well, y equals 2 is the graph of a horizontal line. So from here, if I drew y equals 2, we would intersect the graph 1, 2, 3, 4 times. All right. Another cool color, let's see. Can I be able to? I'm going to use orange. All right. 6. For what values of x does y, or f of x, equal -4? So now this asks the question backwards. It says, when y is -4, what are the values of x? So when y is -4, the values of x are pi and 3 pi. That's it. All right, last one. For what values of x is f of x greater than 0? So what we want to know is, for what values of x are we above so the values of x where we are above the x-axis that are clearly shown, well, 0, 4, well, 0, when x is 0, we are above the x-axis. So 0, 2 pi, and 4 pi. And that's it. That's how you read a graph. That's how you can obtain information from the graph. Okay, perfect. Next one, which is the last one for 3.2. Told you, short, 3.2, nice and sweet. All right. So, given the function x plus 1 over x plus 2, find the domain of f. So remember that x plus 1 over x plus 2, this is a rational function, which means to find the domain, you take the denominator and set it equal to 0, which means you'll get x equals -2, but if x is -2, the denominator becomes 0, and we don't want that. All right, and then in interval notation, you have -infinity to -2, union -2 to infinity. All right, perfect. Next question says, is the point 1 and 1/2 on the graph of f? So this just wants us to check, and the easiest way to check is to plug numbers in. So remember, points are given as x, y. So this means we'll plug 1 in for x, and we'll see if the output gives us 1/2. So we'll say f of 1 equal to 1 plus 1 over 1 plus 2. This gives me 2/3. Which means, no, the point 1 and 1/2 is not on the graph, but the point 1 and 2/3 is on the graph. So that's what we want to know. All right, since 1 and 1/2 is not on the graph, well, it just so happens that 1 and 2/3 is a correct point on the graph. Okay, third one. I guess we could say up here, no. But 1 and 2/3 is. Okay, 3. If x equals 2, what is f of x? And what point does that make on the graph? Hey, simple enough. Plug in 2 and find the value of f of x. So, once again, f of 2 gives me 2 plus 1 over 2 plus 2, and we'll get 3/4. So when x is 2, y is 3/4, and this makes the point 2 and 3/4 on the graph. All right. Get in there, get in there. Now this one asks the question backwards. Now this says, if f of x equals 2, what is the value of x, and what point does that make on the graph? So the last question said when x is 2, but now this one says when y is 2, what is the value of x? So now we have to solve for x. So this means we will get, so since f of x equals 2, this means you set 2 equal to the function x plus 1 over x plus 2 and solve for x. Well, we know we can multiply both sides by x plus 2. So you get 2 times x plus 2 equal to x plus 1. Then you get 2x plus 4 equal to x plus 1. Move the x over, move the 4 over. We get 3x equals, what is that? Move the 4 over, not 3x. It's actually just x, right? X, subtract x. You get x, and then move that over, minus 4, you get negative 3. Perfect. Negative 3. Which means we create the point negative 3, 2. All right. This one, negative 2. Yep. So there is our point. All right. Last one. What are the x-intercepts of the graph, and what points are on the graph? Okay. So for our function, f of x equals x plus 1 over x plus 2. So some fun things to know about a rational function is that domain comes from the denominator. So whenever you solve for the domain, it always comes from the denominator. If you ever want x-intercepts, well, they always come from the numerator, no matter what. So on a rational function, x-intercepts come from the numerator, domain comes from the denominator, which means all we have to do for this one to solve for the x-intercepts is set the numerator equal to 0 and solve for x. We'll get x equals negative 1, which means that creates the point negative 1, 0. And that's it. So given a function, a rational function at that, this is how you can analyze it. You can find the domain, find the points that are actually on the graph by plugging numbers in, and then you can find the x-intercepts. Okay, and I think that is it for 3.2. Told you, really short, not bad. See you at the next one.